Angle sum of a triangle and exterior angles. This is a digital lesson. And the lesson starts with explaining to the students that if you add the angles, all three angles of any triangle, they're always going to add up to 180 degrees. So then students are shown what to do when they've got a missing value. So here we know two of the angles of the triangle, we don't know the third. So we're going to add the three together using algebra, set it equal to 180. They're going to combine like terms here. They're going to get 140, subtract 140 from both sides, and they get the missing angle of 40 degrees. Students are going to be doing this on their own in the next few slides. So this is scaffolded. So the first one they have to solve, they're given the equation. They just have to solve for x. So here they're going to combine like terms. 85 plus 30 will give them 115, and this is still 180. They're going to subtract 115 from both sides, and they get their value of 65 degrees. The next one, students are going to solve. They're given part of the equation. They just have to know this is 180, and then they're going to go ahead and fill in the values to solve for x. And then the next two triangles, they're given the x, and they just have to fill in everything else to solve for the unknown. Next, students are going to be shown an exterior angle. So if I take the base of this triangle and I just extend it as a straight line, then this angle with this angle are going to be supplementary. That means they're going to add up to 180 degrees. So if I add x plus 90, I'm going to get 180 degrees. Subtract 90 from both sides, and I get the missing angle is also 90 degrees. Students are going to be doing that next. So first they're going to have to solve for the missing angle of the triangle, just like we did before. Once they get that missing angle of B, they're just going to subtract it from 180 to get the value of A. The next triangle, this time we extended the line along the top as a straight line. That means D and E are still supplementary. So students are going to solve for D and then subtract D from 180 to get the value of E. And then they've got one more to do that on. Next, students are going to be shown a transversal. So a transversal is a line that bisects two parallel lines. And we want to show students the relationship between the angles when we have a transversal. So the first thing the students need to learn are corresponding angles. So they're in the same position at each intersection. That means they're going to be equivalent. So these two corresponding angles, B and F, they're in the same position at the intersection. So they're going to be equivalent. A and E are also corresponding angles in the same location, and they're going to be equivalent. So the next slide has students just typing in 4 pairs of corresponding angles. So it could be J and N, L and P, I and M, or K and O. Next, they're going to be shown alternate interior angles. Well, interior means they're going to be between the parallel lines, and alternate means they're on opposite sides of the transversal. So they're going to be equivalent. These two angles in red are alternate interior, and the two angles in blue are also alternate interior, and they're going to be equivalent. So then students are going to type in 2 pairs of alternate interior angles. Then they're shown alternate exterior angles. So if they're exterior, then they're outside of the parallel lines and alternate on opposite sides of the transversal. So alternate exterior angles are going to be equivalent also. So the 2 in blue and the 2 in red. And then students are going to type in 2 pairs of alternate exterior angles. Now, this next one is a challenge problem. So if you've got some really advanced students, you might want to just give it to them and see if they can figure it out from what they've learned. Or you might want to walk students through this on the big screen and see if you can figure it out together. So this challenge problem says that, again, we have 2 parallel lines intersected by 2 transversals. And so the challenge is if A, B, and C are supplementary, so A, B, and C, all 3 together are going to equal 180 degrees because they're supplementary. How can we use that knowledge to prove that the angles of the triangle equal 180 degrees? And then the next slide, they're just going to type in their reasoning. So we know that A is going to be the same, okay, because it's one of the supplementary angles and it's also one of the angles of the triangle. Okay, then C and D are going to be equivalent because they are corresponding. And then E and B are going to be equivalent because they are alternate interior angles. It's a little bit of a challenge for the students, so you want to see if they can figure that out from everything they've learned. So this is a digital lesson of angle sum of a triangle and exterior angles.